Assalamualaikum and greetings. Before we start the presentation, I would like to introduce myself and the project's title. My name is Muhammad Zakaria, a student from Chemical Engineering Technology, Faculty of Engineering Technology, UTHM. My final year project title is the production of bioethanol from bamboo powder via dilute sulfuric acid sodium hydroxide treatment and simultaneous saccharification and fermentation under the supervision Technology Student Nasul Fikri bin Cekpa. I will start my presentation with the abstract. Biofuel is a new type of fossil fuel that is usually derived from biomass waste and has the potential to replace commercial fossil fuel. Studies found that lignocellulosic biomass has the potential to become a new source for bioethanol production. Complex chemical structure of LCB made it difficult to utilize the cellulose in the LCB. Treatment of LCB is one of the most crucial steps in converting LCB into bioethanol products. In this study, the potential bioethanol production from Bambusa Wray bamboo via dilute sulfuric acid and sodium hydroxide treatment and simultaneous saccharification and fermentation was explored. The effect of dilute sulfuric acid concentration on glucose concentration produced was studied. Fourier-transform Infrared spectroscopy (FTIR) and dinitrosalicylic DNS acid method were used to characterize the sample. A noticeable decrease in the intensities of absorption peaks in FTIR result can be observed at 1604, 1462 and 1242 after being treated with sequential acid-alkaline treatment. It was reported that 4% dilute sulfuric acid plus 5% sodium hydroxide produce the highest glucose concentration, which is 6.491 mg per milliliter. At the end of the study, bioethanol was absent in the sample due to availability of yeast. Overall, acid-alkaline treatment success in increasing the accessibility of enzyme to substrate and Bambusa Wray capable of producing reducing sugar. For the introduction, I will explain on the background of study, problem statement and objective. For the background of study, biofuel is categorized as renewable energy because the feedstock material for biodiesel can be easily replenished. LCB is one of the most abundant biorenewable materials and the cheapest feedstock for the production of biofuels since it can be easily obtained from agricultural residue, forest products and municipal solid waste. There are various stages for producing bioethanol from LCB, which are LCB pretreatment, hydrolysis, fermentation, and purification of the products. Hence, this study will precisely describe the pretreatment used for LCB before the enzyme and hydrolysis process. The problem statement for this study are the crystalline form of the cellulose and the complex structure of hemicellulose inhibits the enzymatic activities to lignocellulosic substrate. This will result in a low hydrolysis rate in the LCB. Other than that, the destruction of lignin in the LCB is rather difficult due to the complex and rigid structure of the lignin. Due to that, lignin prohibits microbial and pathogenic attacks toward the lignocellulosic substrates. Thus, the objective of this study are to observe the effect of dilute sulfuric acid and sodium hydroxide pretreatment on the chemical structure of the Bambusa Wray. Second, to investigate the impact of different concentration of sulfuric acid during the pretreatment process of Bambusa Wray towards the concentration of glucose produced throughout the simultaneous saccharification and fermentation process. Lastly, to study the effect of different concentration of sulfuric acid on the availability and amount of bioethanol produced during the simultaneous saccharification and fermentation process. For the literature review, biofuel technologies are classified into two classes, which are conventional biofuel and advanced biofuel. Conventional biofuel can be defined as a biofuel that is produced by using eatable crops. On the other hand, advanced biofuel can be defined as biofuel that is generated from agricultural waste and non-food group feedstock. LCB is categorized under advanced biofuel. Next, cellulose, hemicellulose and lignin are the main components for lignocellulosic, while the minor component in the LCB are ash and extractive component. Bamboo is one of the examples of the LCB. Bamboo has a short maturity period and it is ready to harvest in 3 to 5 years. Moreover, studies also found that bamboo is suitable for biofuel stock due to high cellulose content. Next, physical, chemical and biological pretreatment are some of the examples for LCB pretreatment. In this study, the chemical pretreatment was chosen. And lastly, simultaneous saccharification and fermentation was used to produce the bioethanol in this study. For the methodology of this study, the step-by-step procedure was arranged according to the objective of this study. First, Bambusa Wray gum was processed in the fiber extraction machine. Then, the fiber obtained was processed in the planetary bone mill to produce a bamboo powder. The bamboo powder was then treated with a different concentration of sulfuric acid, which is 1, 2, 3 and 4% of concentration. The acid pretreatment was done in autoclave for 1 hour. The bamboo powder was next treated with 5% sodium hydroxide for 1 hour at 85 degrees Celsius. The treated bamboo was then characterized by FTIR to study the changes in chemical structure of the bamboo. After that, pretreated bamboo powder undergoes fermentation. 0.05 molar citric buffer with pH 4.8 was used as a media solution with addition of yeast extract, ammonium sulfate, dipotassium sulfate, epsomite, calcium chloride dihydrate as a nutrient for yeast. 3 ml of 1% cellulose enzyme and 5 ml yeast was added to the media. Fermentation process was undergo for 72, 96, 120 and 144 hours in the incubator cycle at 37 Celsius and 150 RPM. At the end of the fermentation day, some samples were collected to determine the production of glucose during the SSF. Glucose concentration was determined using DNS method. Next, the media solution was processed in the rotary evaporator to extract bioethanol produced during the SSF. The concentration and the availability of bioethanol in the sample is determined by using the FTIR. The methodology for this study cover all the three objectives stated in the chapter 1. Next, the result of the production of bioethanol from simultaneous saccharification and fermentation SSF of pretreated bamboo powder were analysed and discussed. In this study, FTIR spectroscopy was used to study the effect of acid-alkaline pretreatment towards the bamboo powder. The effect of different concentration of dilute sulfuric acid during the pretreatment stage towards the production of glucose during SSF was investigated using the dinitrosalicylic acid (DNS) method. The characterization and amount of the bioethanol produced during the SSF are estimated by using FTIR. For the first analysis, the chemical structure of bamboo after the pretreatment was analysed. Significant changes can be observed in the IR spectra of bamboo composition after undergoing the pretreatment stage. There was an apparent formation of firm peaks around 3425 and 2911, indicating the OH and CH functional groups. Even so, the peak here can be ignored since it is due to the remaining water in the sample and it is far from the bamboo fingerprint region. A noticeable decrease in the intensities of absorption peak can be observed at 1604, 1462 and 1242 after being treated with different concentration of dilute sulfuric acid. This indicates the removal of lignin from the sample. However, the sharp peaks at 1512, which indicates the lignin group, remains constant even after the acid-alkaline pretreatment. A sharp peak around 1157, 1059 and 898 was found after the pretreatment, which indicates the carbohydrates group. From this analysis, it can be concluded that lignin has been successfully removed from bamboo via acid-alkaline pretreatment. Christiani states that acid pretreatment can achieve a high reaction rate and considerably boost the amount of hydrolyzed cellulose. Another study by Song, who investigate the surface characterization and chemical analysis of bamboo substrate pretreated by alkali hydrogen peroxide, found that an alkaline solution can potentially cause the breakdown of a low molecular weight polymer composed of lignin and hemicellulose, as well as breakdown and dissolution of extractive. For the second analysis, the concentration of the glucose produced was determined by using DNS method. From this figure, can be seen that the trend of the glucose concentration increases as the concentration of sulfuric acid during acid-alkaline pretreatment increases. Untreated bamboo powder produced the lowest concentration of glucose, which is 1.158 mg per milliliter. On day 3, commonly, glucose in lignocellulosic biomass is produced via the hydrolysis of cellulose with the help of an enzyme or acid hydrolysis. The high presence of lignin in untreated bamboo reduced the enzyme hydrolysis activities in the sample. This statement was supported with discovery of Zhao during 2011. He found that even though the enzymatic hydrolysis yield was only around 20% after 12 hours, no considerable accumulation of reducing glucose was found in untreated woody biomass at temperature below 180 degrees Celsius. On the other hand, bamboo that has been treated with different concentration of sulfuric acid shows an increasing pattern. At 1% dilute sulfuric acid, 4.561 mg per milliliter of glucose was produced. The amount of glucose keeps increasing, which is 5.575, 5.843, and 6.491 mg per milliliter as the concentration of sulfuric acid increases from 2%, 3%, and 4% respectively. Despite the fact that acid pretreatment does not entirely remove the lignin content in the bamboo sample, acid pretreatment still play a significant role in increasing the susceptibility of cellulose to enzymatic hydrolysis. In a previous study by Zhu, he found that the sequential application of acid and alkaline pretreatment to corn stover resulted in maximum glucose and xylose yield of 89.5% and 97%. respectively. This was accomplished of using cellulose at a dosage of 10 filter paper per unit of substrate. Hence, this proven that production of glucose is affected by the concentration of dilute sulfuric acid. The effect of residence time for fermentation towards the concentration of glucose in the sample has also been discussed. It was discovered that there was a slight decrease in the amount of glucose. The change in glucose concentration for all the sample was too small, which is less than 0.5 mg. Since the change was too few, it was concluded that there was no changes in glucose level for all the sample. Supposedly, the glucose level in the sample should be decreases tremendously as the residence time of the fermentation increase. Glucose will be changed to ethanol and carbon dioxide by an enzymatic process with the assistance of an enzyme in yeast. Fun reported that after an 84 hours fermentation stage, the reducing sugar content in the sample, which was pretreated with 5% sulfuric acid and 5% CHOOH, was extensively consumed. It dropped from 32 to 6.95 gram per liter and 30 to 5.63 gram per liter respectively. Hence, it is expected that the glucose in the sample did not convert to bioethanol by dry yeast. For the last analysis, the availability of bioethanol was determined by FTIR. The infrared peaks formed by the bioethanol were compared with pure ethanol since both solutions have a similar functional group. From this figure, an absorption spectrum with peaks between 3400 to 3200 and 1658 to 168. The broad peak produced between 3400 to 3200 indicates the presence of a hydroxyl group in the sample. In addition, IR peaks forms between 1658 and 1638 show the presence of an alkene group with variable C double bond C bonds between atoms with the moderate intensity. The data obtained shows that there is no formation of a peak which represents the existence of ethanol in the sample. Supposedly, there will be a formation of an absorption wave between 1060 and 1001 that indicates the appearance of the ethanol in the sample. The presence of NIR peaks in that region is due to the absorption band of C-O/vibration. Hence, it can conclude that there is no bioethanol in untreated and treated bamboo sample. Thus, several hypotheses were made to investigate the reason behind the failure of ethanol production during simultaneous saccharification and fermentation. Concentration of glucose was suspected to become a failure of ethanol production. The lowest glucose obtained during the experiment was 1.158, which will represent the untreated bamboo. Theoretically, 1 gram of glucose would produce 0.514 of ethanol and 0.488 of carbon dioxide. Nonetheless, in actual practice, 100% yield glucose cannot be obtained since microorganisms only consume some of the glucose for growth. Chang reported that efficient conversion of glucose to ethanol, which is almost similar to the theoretical value, can be obtained with media containing 10% to 50% glucose concentration for batch cultures. Another research by Palniandi found that 60% of ethanol yield was obtained for pretreated empty fruit bunch with 1.914 mg per milliliter glucose present in the media. From this study, the concentration of the glucose is not a reason for the failure of the bioethanol for this experiment. Next, the condition of dry yeast before the experiment was suspected to become a factor to no bioethanol was produced. Since the dry yeast was not checked before the experiment, a small experiment was conducted to check the condition of the yeast. A 5% glucose solution was prepared and heat up to 37 Celsius. The yeast was then put in a warm water for 15 minutes. If there was a bubble formed in the solution, it indicates the yeast was alive. From this experiment, it was observed that there was no bubble formed after 15 minutes. Thus, it assumes that it died before the experiment was started. Hence, it can be concluded that there is no presence of bioethanol in the sample. It's due to the yeast inactive before the experiment started. In conclusion, acid-alkaline pretreatment successfully removed lignin content in the bamboo and produced glucose during the SSF. The glucose concentration produced was affected by acid concentration during the pretreatment stage. Even so, no ethanol was produced at the end of the study due to the yeast availability. It can be concluded that acid-alkaline pretreatment increased the enzyme accessibility to substrates. Thank you.